Here are some problems from the Math 104 course review packet. Question 2 in that packet says, if f of x equals x squared minus 3x plus 7, find f of negative 2. That will be negative 2 squared minus 3 times negative 2 plus 7. Negative 2 squared is 4. Minus 3 times negative 2 is positive 6. Plus 7 gets brought down. 4 plus 6 is 10. 10 plus 7 is 17. This question says determine whether each relation is a function. Explain why or why not. State domain and range. So we'll state the domain first. The domain is the set of numbers which are the x coordinates. 1, 2, there's another 2, there's the 3, and there's a 4. These numbers 1, 2, 3, and 4, that set of numbers is the domain. The range is the set of the y coordinates, which are 3, 2, 1, 4, and 5 in any order. 3, 2, 1, 4, and 5. And determine whether each relation is a function. This is not a function because there are 2 points with the same x coordinate. Two points with the same x coordinate make it not a function. To simplify question number 8, the 2 with the negative 3 exponent, you can make that 2 with the positive 3 exponent by bringing that circled thing from the numerator to the denominator. The negative 3, which is to the first power, would stay in the denominator. The x with the negative 3 exponent can go up to the numerator and become x to the positive 3. This x, which is to the first power, will stay in the numerator because it already has a positive exponent. And the y with the negative 1 exponent move up to the numerator, make it y to the first. So the purple moved up, the thing in the purple moved up, the thing in the blue moved down, the thing in the green moved up. The negative 3 just stays where it is. And so does the x with the red circle around it. It stays where it is. In multiplying, like the red and the green, with same base, we keep the base and add the exponents. 1 plus 3 is 4. The y to the first power is y in the numerator. 2 to the third means 2 times 2 times 2, which is 8. And 8 times negative 3 is negative 24. So that actually would be an okay way to give the answer, but it's ordinarily written x to the fourth y over 24. With that negative in front of the 24 can go here, just showing that the entire expression is negative. Because a positive divided by a negative equals a negative. Exercise 9. The 27 has a 1 exponent. So we're going to keep the base, and the inside exponent and the outside exponent get multiplied 1 times 2/3, this exponent. Same with the x. Keep the base, and 12 times 2/3 will be the exponent. 12 times 2/3 is 24/3. And with the y, we keep the base, and 15 times 2/3, which is 30/3. That's how we get rid of the parentheses. The inside and outside exponents get multiplied. 27 to the 2/3, that's power over root. So we make a root symbol with 27 inside. Power over root, so 3 is the root. And the 2, the top number, is the power. Next to that, we have x to the 8th, because 24 over 3 is 8. And next to that, we have y to the 10th, because 30 over 3 is 10. The cube root of 27 is 3. So the 3 has to get raised to the second power. Everything else gets brought down because it is as simple as you can get it. But 3 squared means 3 times 3. So the final answer is 9x to the 8th, y to the 10th. These are simplified. To factor a sum of perfect cubes, we get a binomial times a trinomial. The cube root of the first term, which is 5a, goes here. 5a times 5a times 5a is 25a to the third. The cube root of the second term goes here. It's positive 2, because positive 2 times positive 2 times positive 2 is positive 8. 5a times what I write there has to be the first term in the given. So I'm going to write 25a squared. Because the two red things multiplied equals 125a to the third. Positive 2 times the term I write way down here has to be positive 8. So I'll write positive 4 here because positive 2 times positive 4 is positive 8. The middle term is the product of the two terms written there, but with the opposite sign. That means the middle term is negative whatever 5a times 2 is, which is 10a. So I'm going to rewrite the answer. That's actually the answer. I'm going to write it again. It's 5a plus 2 in parentheses times 25a squared minus 10a plus 4. To add fractions, we need the common denominator. So first thing we do is factor each denominator. The first denominator is x plus 5 in factored form, and the other denominator underneath the 24 is x plus 5 times x minus 3. The common denominator is x plus 5 times x minus 3. So that's what I just said is the denominator for both of these fractions, x plus 5 times x minus 3. Then, whatever I multiplied to this to make it that, I have to multiply the numerator by the same thing. Since I multiplied the denominator, x plus 5, by x plus 3, I have to multiply this numerator by x minus 3, is what I meant to say. And this other fraction just gets brought down. So these fractions are equivalent to the originals. Then we just write the numerator plus the other numerator all over the common denominator. This numerator is 3x minus 9. And we write plus the other numerator all over the common denominator. And negative 9 plus 24, those are like terms. Negative 9 plus 24 is positive 15. 3x plus 15 all over the common denominator. And this is not simplified yet because 3x plus 15, 3 can be factored out of x plus 5. That's the same as 3x plus 15. And because it is over x plus 5 times x minus 3, The final answer is just 3 over x minus 3. Because up here, I want to repeat, this is just a different way to write that. And then the final answer is obtained by canceling x plus 5 in the numerator with x plus 5 in the denominator. To multiply fractions, we do not need to get a common denominator. We just need to factor every numerator and every denominator. This numerator is the same as x times x minus 4. This denominator can be factored. X plus 2x plus 4. This numerator, x plus 2, is the same as x plus 2. You could say times 1 if you want. And this denominator, x squared minus 16, that can be factored. X plus 4, x minus 4. So 4 things got factored: red and green and black and blue. Then the x plus 4 up here cancels with x minus 4 up here cancels with x minus 4 down there. And x plus 2 up here cancels with x plus 2 down there. What's not crossed out on the top is just x times 1. On the bottom, not crossed out, is x plus 4 times x plus 4. If you want to, you can write that as x plus 4 squared. Or this could be a final answer, or x over x squared plus 8x plus 16. I say or because either answer is considered simplified. X plus 4 times itself is this trinomial, x squared plus 8x plus 16. To simplify this, the 5 gets cut down, and the root 32 we split into a root times a root. Let's use 16 times 2. That minus sign gets brought down. The root 72 we're going to split into a root times a root 36 times root 2. Then we bring down the 5. The square root of 16 is 4. The root 2 gets brought down. The minus sign gets brought down. The square root of 36 is 6. And the root 2 we bring down. 5 times 4. So we have 20 root 2 minus 6 root 2. We combine those like terms or like radicals. 20 root 2 minus 6 root 2. We get 14 root 2. To simplify this, we just factor the numerator and the denominator. The numerator is the difference of perfect squares, x plus 6 times x minus 6. The denominator we factor using trial and error. It's x minus 6 times x plus 3. And then after we cancel, we'll have x plus 6 on the top and x plus 3 on the bottom. Because x minus 6 divided by x minus 6 is 1 over 1. In this complex fraction, y times y minus 3 is the common denominator of these little fractions to make up this big fraction. We're going to take what I just wrote in blue times the 2 over y, and then a minus. We're going to write the same thing in blue, y times y minus 3 times the next term here, 4 over y minus 3. And then we have this, I like to make this up. I like to make this purple to show you that it's over here. Purple. We take the y times y minus 3 times the 1 over y term. Then there's a plus. So we take y times y minus 3 times that 3 over y minus 3 term. So this messy thing here is just the original fraction with every term being multiplied by the blue. And then the next line, I'll write it and then show you how I got it. This blue up here times this black is just 2 times y minus 3. And then after this minus sign, this blue times this black is just 4y. Here's the purple line. Below the purple line, y times y minus 3 times 1 over y is just 1 times y minus 3. And then after the plus sign, the blue times the black is just 3y. Because to get to this much simpler thing, we're just canceling this up there with this down there, and this up here with this down there, this up here with this down there, and this up here with this down there. This is down here is just what's not crossed out. Now the 2 up here and the 1 down here are going to get distributed. 2 times y minus 3 is 2y minus 6. The minus 4y gets brought down. Purple line. 1 times y minus 3 is y minus 3, and the plus 3y gets brought down. And now we'll combine like terms. On top, 2y minus 4y is negative 2y, and there's still a minus 6. On the bottom, y plus 3y is 4y, and there's still a minus 3. This is as simple as we can get it. You can factor a 2 or a negative 2 out on the numerator, but it won't be any simpler if you do that. But you could do that if you felt like it. To solve a radical equation, we first isolate the radical, which in this problem means move the 5 from the left side of the equal sign to the right side. Could also say subtract 5 from both sides. So the square root of 4x plus 8 is equal to 6. And then we square both sides. Here's the left side squared, right side squared. We square both sides because the square root of 4x plus 8 squared is just 4x plus 8. And the other side, 6 squared is 36. Move 8 to the other side. Or say subtract 8 from both sides. And get 4x equals 28. And then divide both sides by 4. 28 divided by 4 is 7. You should check this in case this is an extraneous solution. So I'll do a little bit of checking over here. 4 times 7 is 28 plus 8. That's inside the radical symbol with a 5 plus in front of that. Make sure that this equals 11. 28 plus 8 is inside the radical. 28 plus 8 is 36. That's inside the square root symbol with a 5 plus. and the square root of 36 is 6. Is 5 plus 6 equal to 11? 11 does equal 11. Since this is true, we know this is the correct solution. X equals 7. To solve this equation, we're going to first factor every denominator. X squared minus 25 is x plus 5 times x minus 5, plus 1 over x plus 5 in the factored form, like so. Put a 1 in front if you want. After the equal sign, 8 over x minus 5 in factored form. A 1 in front if you want. So now, similar to this problem where we multiplied every term by the least common denominator, every term on the top and on the bottom, here we're going to multiply every term on the left side of the equal sign and the right side of the equal sign by the common denominator. X plus 5 times x minus 5. Multiply that by the 3 over x plus 5, x minus 5. Then there's a plus sign, so we multiply the next term by the red common denominator. Then we say anything we do to one side of the equal sign, I'll make the equal sign purple, so you could relate it to that last problem about the complex fraction. If we multiply the left side by the red, we have to multiply the right side by the same thing. So there's the common denominator times the 8 over x minus 5. So then this horrible looking thing, it's the same as what's above, except every term is being multiplied by the x plus 5, x minus 5, which is red. And now the next thing we write is just 3 plus 1 times x minus 5 equals 8 times x plus 5. That turned out so simple because x plus 5 cancels, x minus 5 cancels. It's just a 3 left. Over after the plus sign, x plus 5 cancels. 1 times x minus 5 is not crossed out. After the equal sign, x plus 5 up, x minus 5 up there and x minus 5 down there. 8 and x plus 5 do not cancel. So now we'll distribute to get rid of these parentheses. 3 plus 1x minus 5 equals 8x plus 40. The left side is now 1x minus 2 because 3 minus 5 is negative 2. Now here's the equal sign. I'm going to write every term with x on the left side of the equal sign, and then every term that does not have x on the right side. So the minus 2 is now a plus 2. And the 8x is now a negative 8x. The other terms, the 1x and the 40 just got brought down. 1x minus 8x is negative 7x. 40 plus 2 is 42. Divide both sides by negative 7. 42 divided by negative 7 is negative 6. 42 divided by negative 7 is negative 6. To solve a quadratic equation by completing the square, we first move the constant term, in this case the 22, to the other side of the equal sign. Positive 22 on the other side of the equal sign becomes negative 22. Then we take half of the number multiplied to y, half of 10. Whatever that is, we square it. Half of 10 is 5, and when you square that, you get 25. complete the square means, in this problem, means add 25 to both sides. Add 25 to both sides. By doing that, y squared plus 10y plus 25 can be written as y plus 5 squared. Y plus 5 times y plus 5 is y squared plus 10y plus 25. And the other side in this problem is 3. 25 minus 22 is 3. And then we take the square root of both sides. Don't forget to write plus or minus, because the square root of y plus 5 squared is just y plus 5. And the other side of the equal sign, we just leave it like that. Plus or minus the square root of 3. And then this positive 5 moves to the other side of the equal sign, turning into a negative 5. Bring down the plus or minus the square root of 3. That's it. To perform this operation, we take 3 plus 2i. 3 plus 2i squared means 3 plus 2i times itself. To multiply these, we take 3 times 3. That's 9. 3 times positive 2i is positive 6i. Positive 2i times 3 is positive 6i. And positive 2i times positive 2i is positive 4i squared. But everybody knows that the number I squared is equal to the number negative 1. Nine brings down bring down the 9. 6i plus 6i is positive 12i. And at the end here, we have plus 4 times negative 1. 4 times negative 1 is negative 4. So we have 9 plus 12i minus 4. But 9 minus 4 is 5. So the final answer is 5 plus 12i. To simplify this, we multiply the denominator by its conjugate. The conjugate of 3 plus 7i is 3 minus 7i. If we multiply the denominator of a fraction by 3 minus 7i, we have to multiply the numerator by the same thing. In the numerator, we're going to just leave it for a minute. We're going to leave the 4 times 3 minus 7i that we see up there. But down below, we're going to do the same thing we just did here. FOIL. That would be 3 times 3, which is 9. 3 times negative 7i is negative 21i. 7i times 3 is positive 21i. And 7i times negative 7i is negative 49i squared. And as you know, I squared is negative 1. So we'll keep 4 times 3 minus 7i on top. But on the bottom, we just have 9 minus 49 times negative 1. Because negative 21i plus 21i is 0. And I squared is negative 1. That's negative 49 times negative 1, which is positive 49. So on the denominator, we have 9 plus 49. Which is 58. Actually, I feel like I should distribute the 4 after all. So on the top, we have 4 times 3, which is 12, and 4 times negative 7i, which is negative 28i. And 9 plus 49 on the bottom is 58. To have the answer in a plus bi form, we split this fraction by writing just the first term, 12, over the denominator, and then a minus, what we see there as a minus, the second term over the same denominator, but not simplified, which is what the directions say to do, because 12 over 58 can be reduced to 6 over 29. And 28 over 48 can be reduced to 14 over 29. This term after the minus sign has the I attached to it. This is considered A plus BI form. And simplified. 12 and 58 and 28 are all even numbers, so they can all be divided by 2 to reduce the fractions or simplify. For this problem, we're going to make a right triangle. Angle C is 90 degrees, so we'll put the C here. A could be up here. That's capital A, means angle A. Capital B, you can interchange the A and B, but the C has to be the right angle. Little a equals 2 means the side opposite angle A is equal to 2 inches or feet or something. The little b equals 5 means the side opposite angle B, the length of that side is 5. To find the third side opposite angle C, we don't know that yet. I'm going to use a squared plus b squared equals c squared. Little a is given, little b is given, and we're doing this so we can find little c. C is the hypotenuse across from the right angle. 4 plus 25 equals c squared, so 29 equals c squared, so the square root of 29 is equal to c. I think I'll erase this question mark and put the square root of 29 there. To find the 3 trigonometric functions of angle A, that means we want the sine of angle A, the cosine of angle A, and the tangent of angle A. And I remember some old horse caught another horse taking oats away, which means the sine of angle A is opposite over hypotenuse. Opposite angle A is a 2, and the hypotenuse is the square root of 29. Caught another horse means cosine is adjacent over hypotenuse. Adjacent to angle A is a 5, and the hypotenuse is the square root of 29. The tangent of angle A, taking oats away, means tangent is opposite over adjacent. Opposite angle A is a 2, and adjacent to angle A is a 5. To rationalize these denominators, 2 over root 29 becomes 2 root 29 over regular 29. 5 over root 29 becomes 5 root 29 over regular 29. And 2 over 5 is as simple as it can be. So that's it. Those are the exact values of the 3 trigonometric functions of angle A. Here we'll need another right triangle. Angle C is 90 degrees. Angle A and angle B. Angle B is given, 42 degrees. The 3 angles of a triangle always add up to 180. So capital A plus capital B plus capital C has to equal 180 degrees. Angle A, we don't know yet. Angle B is 42 degrees, and angle C is 90 degrees. When we add 42 and 90, we get 132. So angle A plus 132 has to equal 180. Subtract 132 from both sides. 180 minus 132 is 48. Angle A must be 48 degrees. That's one of the answers because it says find all other angles. Angle C and angle B were given, so there's only one other angle. Little a is 9, so across from angle A is 9. The distance from B to C is 9. To find little b, that's across from angle B, we're going to use tangent, because the tangent of 42 degrees, tangent is taking oats away. That means tangent is opposite over adjacent. Opposite over adjacent. Opposite angle B is little b, and adjacent angle B is 9. So we're going to put a 1 here and then cross multiply. B times 1 is B. The other cross product is the number 9 times the tangent of 42 degrees. On your calculator, you press 9 times the tangent of 42 degrees. And the directions say to give the answer to the nearest tenth, so we're going to make this, we're going to round this to 8.1. So B rounded to 1 decimal place, 8.1. So we know B now. To find angle C, we can use cosine, or you could use the Pythagorean theorem, but I'm going to use cosine. The cosine of angle B, caught another horse. Cosine is adjacent over hypotenuse. Adjacent to 42 is 9, and C is the hypotenuse. Cosine is adjacent over hypotenuse. This time when we cross multiply, we'll have that little c down below there times the cosine of 42 up there equals 9 times 1 is the other cross product. Divide both sides of this equation by cosine 42. I said divide both sides of this equation by cosine 42 to get the c all by itself. That's a little c. And then type in 9 divided by cosine 42 on my calculator. 9 divided by cosine 42. And to the nearest tenth, that's 12.1. So I think we're done with this problem because we have all the sides of the triangle. A was given and we found B and C. And the angles B and C were given and we found angle A. This question says determine whether this is a function. Express the domain and range. So the domain is the x values. This is the x-axis. There's no x value to the left of this vertical line, and there's no x value to the right of this vertical line. So we would say that the x values are between, that's less than symbols on both sides, between 1 and 5. But 5 is included because this point is part of the graph, and x is 5 at that point. But the 1 is not included because even though the graph goes up to this purple broken line, there is no point here where x is 1. So the 1 is not included. The range is the y values, and this is the y-axis. There's no y value lower than this broken line. There's nothing lower than that. And there's nothing higher. There's no y value higher than this. So we write the y variable with less than on both sides. There's no y lower than 0. and there's no y higher than 4. 0 is included because there is a point. It's right here. At that point, y is 0. That's the point 4, 0. But there is no point where y is 4. The graph goes up to that, but doesn't include. The domain and range could also be written like this. The domain could be written parentheses 1, comma 5, bracket, and the range could be written like this. Bracket 0, comma 4, parentheses. And determine whether this is a function. This is not a function. I can tell by the vertical line test. Here's a vertical line. Actually, I'm going to make a better one. Here's a vertical line that touches more than one point, because it touches this point, which is part of the function, or part of the graph, I should say, and it touches the point 4, 0, which is also part of it. If a vertical line touches more than one point, if a vertical line can be drawn that touches more than one point, then the graph is not a function. To graph this parabola, we start with x equals negative b over 2a. In this case, negative b is going to be negative 6. And on the bottom we have 2 times a. A is 1. This is negative 6 over 2. So the axis of symmetry is x equals negative 3. Negative 6 divided by 2 is negative 3. Now let's make a table with an x column. We'll make a column with x squared plus 6x plus 5. And we'll make a y column. Let's make 7 entries in this table with this number in the middle spot. Numbers bigger than negative 3 are negative 2, negative 1, and 0. Numbers smaller than negative 3 are negative 4, negative 5, and negative 6. So we'll plug these numbers in for x in this middle column. Negative 6 squared is 36. 6 times negative 6 is negative 36. The plus 5 is called a constant. Plus 5 is, when we say constant, it means it does not change. No matter what we plug in for x, the plus 5 will stay a plus 5. Negative 5 squared is 25. 6 times negative 5 is negative 30. 25, oh, I forgot to fill this one. 36 minus 36 is 0. 0 plus 5 is 5. 25 plus 5 is 30, and 30 minus 30 is 0. Negative 4 squared is 16. 6 times negative 4 is negative 24. 16 plus 5 is 21. 21 minus 24 is negative 3. Negative 3 squared is 9. 6 times negative 3 is negative 18. 9 and 5 is 14, and 14 minus 18 is negative 4. Negative 2 squared is 4. 6 times negative 2 is negative 12. 4 plus 5 is 9. 9 minus 12 is negative 3. Negative 1 squared is 1. 6 times negative 1 is negative 6. 1 plus 5 is 6. 6 minus 6 is 0. 0 squared is 0. 6 times 0 is 0. 0 plus 5 is 5. So we're going to plot the points from this table, starting with negative 6, 5, which would mean left 6 and up 5. This is the x-axis and this is the y-axis. Then we have negative 5, 0. 1, 2, 3, 4, 5. That's negative 5, 0. Negative 4, negative 3 means to the left 4. 1, 2, 3, 4, and down 3. 1, 2, 3. Negative 3, negative 4 means to the left 3 and down 4. 1, 2, 3, 1, 2, 3, 4. Negative 2, negative 3 means to the left 2 and down 3. Left 2, down 3. Negative 1, 0 means to the left 1. And then 0, 5 means 0 and up 5. So axis of symmetry, we already wrote that there. I'll just write the word axis to save time. The vertex is also called the turning point. It's right in the middle of this table. It's the point -3, -4. So we got that. X-intercept is when y is 0. So look in the y column right here and here. So -5, 0 and -1, 0. Those are where the graph crosses the x-axis. We call those x-intercepts. And y-intercept is when x is 0. So look in the x column, there's 0, 0, 5 is called the y-intercept. 0, 5 is where the graph crosses the y-axis. I think that'll be more precise here. That's called the axis of symmetry. You don't have to draw it in, but it will. If you do draw it in, it would be a vertical line. It's not necessary to draw it, so I'm not going to. So here we're going to pick two equations and eliminate either x, y, or z. Pick any two equations. I'll pick the first two, and I'll eliminate x by multiplying the top equation by 5 and the middle equation by -3. So the m means multiply. I'm multiplying the top equation by 5. 3x times 5 is 15x. -2y times 5 is -10y. 4z times 5 is +20z. -1 times 5 is -5. The middle equation multiplying by -3, 5x times -3 is -15x. -3y times -3 is +9y. And 5z times -3 is -15z. And 2 times -3 is -6. And we add these columns. The x column cancels out. The next column is 9y minus 10y, which is -1y. The z column is 20z minus 15z, which is +5z. And after the equal sign, we have -5 and -6, which is -11. And now we want another equation that only has y and z in it. So we will eliminate x from the middle column and from the middle equation and the third equation. And we can do that if we multiply the middle equation by 6 and the third equation by -5. 5x times 6 is 30x. -3y times 6 is -18y. 5z times 6 is 30z. And 2 times 6 is 12. Third equation multiplied by -5. 6x times -5 is -30x. -2y times -5, negative times negative, so it's +10y. 3z times -5 is -15z. And 5 times -5 is -25. When we add the columns, the x column cancels out. 10y minus 18y is -8y. 30z minus 15z is +15z. And 12 minus 25 is -13. So now we have this other equation that has only y and z in it, just like the one down there. So I'm going to just copy the equation that we just got from up there. I'm going to just copy it. -8y plus 15z equals -13. And I'm going to multiply this equation by -8. Because -1y times -8 is +8y. 5z times negative 8 is negative 40z. And negative 11 times negative 8 is positive 88. I'm multiplying this equation by negative 8. And we already had, in this equation up here, we already had a negative 8y. When we add these columns, the y column disappears. And 15z minus 40z is negative 25z. And 88 minus 13 is 75. Divide both sides by negative 25, and we get z equals negative 3. And now we're going to plug that result into one of these two equations that have a cloud around them. I'll use this one right here. Negative 1y plus 5 times z, we know z is negative 3 now, equals negative 11. So we have negative 1y minus 15 equals negative 11. Move negative 15 to the other side. Negative 11, we're adding 15 to both sides. And negative 11 plus 15 is 4. Divide both sides by negative 1. 4 divided by negative 1 is negative 4. Then we plug both of these results into any one of the original equations. So I'll pick the top equation, 3x minus 2y plus 4z. I have to scroll back again. I already forgot. 3x minus 2y plus 4z equals negative 1. I'm picking the first equation, but you can use any one of the original three here, where we say 3 times x, we don't know x yet, minus 2 times y, we know y equals negative 4, plus 4 times z, z is negative 3, equals negative 1. So 3x, this is a negative times a negative, so that's plus 8. This is a positive times a negative, so that's negative 12. 8 minus 12 is negative 4. Move negative 4 to the other side. On the other side becomes plus 4. Negative 1 plus 4 is 3. And divide both sides by 3. 3 divided by 3 is 1. So in alphabetical order, x is 1, y is negative 4, and z is negative 3. X comma y comma z. To solve this system of equations, we can replace this y with 2 minus x. From the x plus y equals 2, y has to equal 2 minus x, because I've moved the x to the other side, or subtracted x from both sides. So what I'm saying here is, instead of writing the y, we can write what y equals, and then everything else, just copy this. Replace y with what y equals from the other equation. Or you could replace x with what x equals. There's many options. This quadratic equation we're going to solve by making one side 0. That means the red 2 becomes a negative 2, and the red negative x becomes a positive x. Moving these red terms to the other side of the equal sign. The 2 becomes negative and the x becomes positive. Combine like terms. We have an x squared. We have a negative 4x and a positive 1x, which is negative 3x. And we have 4 minus 2, which is positive 2. Maybe we can factor this. think that's factored correctly. -2 times -1 is +2. Outers and inners check. Set each factor equal to 0. Add 2 to both sides. 0 plus 2 is 2. Add 1 to both sides. 0 plus 1 is 1. When x is 2, plug 2 into here. When x is 2, y is 2 minus 2. From way up there in the red. So we figured out that when x is 2, y comes out to be 0. When x is 1, we still use y equals 2 minus x, or the other equation. I'm just picking the simpler one. Y is equal to 2 minus whatever x is. X is 1. So we found out that when x is 1, when x is 1, y is also 1. So this is a semicolon. That's it. If we were to graph these two things, by the way, x plus y equals 2 is a line. In the other equation, graph would be a parabola. The line and the parabola would intersect at the point 1, 1. The line would also intersect the parabola at the point 2, 0. You could practice graphing those if you want, but that's not part of the problem. We found the intersection points without graphing. A fence rectangular area. Let's draw a rectangular area. Is 300 square feet. The width is 5 less than the length. So I'm going to use L for the length, and the width is 5 less than the length. So it's whatever the length is minus 5. To write the area, make this red, 300, that means you take the length times the width, and that equals the area. The length of a rectangle times the width equals the area. Distribute the L. L times L is L squared. L times -5 is -5L. I think I'm going to try to solve this by completing the square instead of trying to factor. To complete the square, we take half of 5. 5 is the number multiplied to L. You can ignore the negative in this process. Whatever half of 5 is, you square that. Well, half of 5 is 2.5. And when you take that 2.5 and square it, you get 6.25. So to complete the square, that means in this problem, we add 6.25 to both sides. The reason completing the square is useful is the left side of the equal sign is now the binomial L minus 2.5 squared. If you take L minus 2.5 times L minus 2.5, it's going to equal this trinomial. The other side of the equal sign is 306.25. Then we take the square root of both sides. The square root of both sides. The square root of the left side equals plus or minus the square root of the right side. And that's a good thing because the square root of L minus 2.5 squared is just L minus 2.5. And believe it or not, the square root of 306.25 is exactly 17.5. I'll show you. The square root of 306.25 is exactly 17.5 because 17.5 times itself is 306.25. That's the reason it's right. So there's no approximating here. It's exactly that. Move the minus 2.5 to the other side. So L equals this minus is going to turn into positive 2.5 plus or minus 17.5. That means the length of the rectangle could be 2.5 plus 17.5, or the length of the rectangle could be 2.5 minus 17.5. 2.5 plus 17.5 is 19. And this will be a negative number. It's impossible for the length of a rectangle to be a negative number. So the length of the rectangle is 19 feet. And the other side is labeled L minus 5. Whatever L is minus 5, that in this case would be 19 minus 5, which is 14. So we have a mistake. So let me see where the mistake is. Okay, I'm going to carefully read all this over again to find a mistake, because the answer key is not getting this. The width is 5 less than the length. Area is 300. L squared minus 5L. Half of 5 is 2.5. 2.5 squared is 6.25. I think I see the mistake. No, that's not a mistake. Here's the mistake, is right here at the end. 2.5 plus 17.5, it is 19. Okay, something is wrong. Let me pause this video, see if it'll pause. I guess this is still recording. Anyway, here is the mistake. 2.5 plus 17.5 is 20. So the mistake is I don't know how to add. 17 and 2 is 19, but there's these two halves, so that's 20. And 20 minus 5 is 15. So finally, we have the correct answer is 20 feet by 15 feet. That was silly. Let me get rid of this. So yeah, everything was correct except the very end when I had trouble adding 2.5 and 17.5. That's actually 20, not 19. Sorry about that. Jan can travel 5 miles on her rollerblades in the same time Tran Lee can travel 8 miles on his mountain bike. Let's make a table with rate, time, and distance. Jan and Tran Lee. Jan can travel 5 miles, that's distance, on her rollerblades in the same time Tran Lee can travel 8 miles, that's distance, on his mountain bike. If Tran's speed is another word for rate, on his bike is 6 miles per hour faster than that of Jan on her rollerblades. So Jan, near the end of the sentence, will get a rate of X. Tran's speed is 6.3 miles per hour faster than Jan. So instead of X, it's X plus 6.3. The time column is whatever I put in the distance column over the rate. Rate times time is equal to distance. So if time is not filled in, it's whatever is in distance space over whatever's in the rate. Time is always distance over rate. And I know these times are the same It says so right here. That means they're equal. The time for Jan, which is what I wrote under time for Jan, and the time for Tran Lee, I know those are the same because it says so right there, circled in purple. And now I can solve this by cross multiplying. The cross product 5 times x plus 6.5 equals the other cross product 8 times x. Distribute the 5. 5 times 6.5 is 32.5. Let's copy the 8x and move the 5x over to this side. Leave the 32.5 right where it is. Eight x minus 5x is 3x. And I already have a mistake. I'll fix it before we go on though. This is supposed to say, I'm getting tired, right? 6.3. That means this should say 6.3. And 5 times 6.3 is 31.5. Caught this mistake before we finished. We were almost finished. And then divide both sides by 3. 31.5 divided by 3 is 10.5. And the x equals 10.5. X is under rate for Jan. Jan's rate, 10.5 miles per hour. And then x plus 6.3, whatever x is, add 6.3. That's going to come out to be 16.8. So x plus 6.3 is under rate for Tran. So Tran's rate is 16.8 miles per hour. Just took the x and added 6.3. Okay, so maybe I shouldn't go so fast and I won't make so many mistakes. The height of a fireworks rocket with an initial velocity of 128 feet per second shot from the top of a 200-foot cliff is a function of time given by this formula. To find how long it takes for the rocket to reach maximum height, we use the formula from the parabola problem a little while ago, except instead of x, we're going to use the t for time, but negative b is going to be negative 128 over 2 times a. A is negative 16. So t equals negative 128 over negative 32. And a negative divided by negative is a positive. So negative 128 divided by negative 32 is positive 4. T is time, and this is the time is seconds. This is the number of seconds it takes for the rocket to reach its maximum height. That would be the turning point of the parabola when t equals 4 seconds. To answer part B, we just take the 4 seconds and plug it in there. The height of the fireworks after 4 seconds is negative 16 times 4 squared plus 128 times 4 plus 200. We're just using this and plugging 4 in for all of the t's. That's negative 16 times 4 squared, which is 16. 128 times 4 is 512. The plus 200 is constant. Negative 16 times negative 16 is negative 250. I mean, negative 16 times 16 is negative 256. Add 512, and then add 200. Negative 256 plus 512 plus 200 is 456. That's the height of the fireworks after 4 seconds. And that would be the maximum height of the rocket. I mean the fireworks. I guess it is a rocket. Because that would be the turning point of the parabola, the highest point. To find how long it takes for the rocket to hit the ground, we make the height of the rocket 0. Because if it's on the ground, the height is off the ground is 0. To answer part C, we make this thing there, make the height 0, and then solve this equation for t. Okay, this is not an easy equation to solve. And we're going to have to round our answer, so I think we should use the quadratic formula. Before we use the quadratic formula, let's multiply or divide both sides by -1. So that negative 16 will become a positive 16. That positive 128 will become a negative 128. And that positive 200 will become a negative 200. In this form, it's usually best if a is a positive number. That's why I changed all the signs. Positive, negative, negative. A is 16, B is negative 128, and C is negative 200. So the quadratic formula is t, we're solving for t, equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So t equals negative 128 plus or minus the square root of negative 128 squared minus 4 times a is 16, times c is negative 200, all over 2 times a is 16. So I'm going to do a lot of this on the calculator. Negative, negative, so it's positive 128 plus or minus. Negative 128 squared is positive 16384. And we're going to have a plus here because a negative in the formula and another negative here. Negative times negative, so we end up with plus something. 4 times 16 times 200 is 12,800. And that's all over 2 times 16, which is 32. Inside the radical, 16,384 plus 12,800 inside the square root sign. Wait a minute. Haste makes waste. Inside the square root sign, add those numbers, and I got 29,184. Just double checking. That's all over 32. And the square root of 29,184, I'm going to round this. This is an approximation now. 128 plus or minus 170.833 all over 32. So the time it takes for the rocket to reach the ground, that means the height of the rocket is 0, is either 128 plus 170.833 divided by 32, or the time it takes to reach the ground, 128 minus 170.833 over 32. When we add the numbers in the numerator over here, we get 298.833, and that's over 32. The other one we reject. 128 minus something bigger, that's going to be a negative number. The time it takes will not be a negative amount of time. When we take 298.833 and divide by 32, we get to the nearest tenth, 9.3 seconds. The time it takes to reach the ground is approximately 9.3 seconds. I say approximately, but it's very accurate. It's just not exactly 9.3 seconds. Maybe a teeny tiny bit longer, but not as much as 9.4 seconds. But okay, so thanks for your patience, and that's the end.